In the summer of 1665, plague closed the University of Cambridge and sent everyone home. One of them was a 22-year-old undergraduate of no particular distinction, who went back to his mother's farm in Lincolnshire with nothing to do. Over the next 18 months, alone in that house, he invented calculus, took sunlight apart, and proved white light is every color at once, and worked out the law that holds the moon in the sky. Any one of the three would make a career. He did all three before he turned 25, told almost nobody, and went back to university. Isaac Newton would go on to write the single most important book in the history of science, hunt counterfeiters to the gallows, and write more words on alchemy than on physics. This is the story of the strangest mind England ever produced, and what he understood that nobody around him did. He was born on Christmas Day, 1642, 3 months after his father died, so small that his mother said he would have fit inside a quart mug. Nobody expected him to survive the week. When he was 3, his mother remarried a wealthy elderly clergyman who wanted a wife, but not a stepson, and Isaac was handed to his grandmother and effectively abandoned for 8 years. We know exactly how that felt to him, because at 19 he wrote out a list of his sins, and one of them reads, "Threatening my father and mother to burn them and the house over them." He grew into a boy who built things instead of speaking: sundials, water clocks, a working model windmill powered by a mouse, and kites carrying lanterns that he flew at night to frighten the neighbors. When his mother pulled him out of school at 16 to manage the farm, he was so bad at it that he was fined for letting his sheep wander into someone's corn. He was found reading under a hedge while the animals escaped. The schoolmaster persuaded his mother to send him back. He went up to Trinity College, Cambridge, in 1661 as a sizar, a student who paid his way by waiting on wealthier undergraduates, emptying their chamber pots and eating their leftovers. He was taught Aristotle, ignored it, and read Descartes and Galileo on his own instead, filling a notebook under the heading, "Certain Philosophical Questions." Then in 1665, the Great Plague reached Cambridge, the university shut, and he went home. What happened in the next 18 months has no real parallel. He developed the mathematics of change, what we now call calculus, because the problems he wanted to solve had no maths yet, so he built it. He bought a glass prism at a fair and did something nobody had thought to do. He put a second prism in the path of the split beam and proved the colors were in the light all along, not added by the glass. And he asked why the moon does not fall, and got the answer that it does, continuously, and that the same force pulling an apple to the ground reaches all the way up to hold it there. And then he did nothing with it. He returned to Cambridge, was made a fellow, and then, at 26, Lucasian professor of mathematics, and lectured to rooms that were sometimes empty. His first public act was a machine, the reflecting telescope, built with his own hands, mirror ground, metal cast, tube made, a device the length of your forearm that outperformed telescopes 20 times its size. The Royal Society was astonished and elected him. So he sent them his theory of light, and it went badly. Robert Hooke, the Society's curator of experiments, dismissed it briskly. Newton, who had expected agreement, responded with a fury out of all proportion, and then simply withdrew. He stopped publishing, ceased corresponding, and told a colleague he had sacrificed his peace, a thing of real substance. The most productive scientist alive spent the next decade largely writing in private, and the work of the plague year sat in his drawer for 2 more decades. He was not being modest. He could not bear being argued with. In August 1684, a young astronomer named Edmund Halley took a coach to Cambridge with a question that London's cleverest men could not answer. Suppose the force pulling the planets falls off as the square of the distance. What shape would an orbit be? Newton answered immediately, an ellipse. Halley, startled, asked how he knew. Newton said he had calculated it. And then, hunting through his papers, he could not find the proof. Halley left with nothing but a promise. 3 months later, a 9-page treatise arrived in London, and Halley understood that he was looking at something enormous. What he did next matters as much as anything Newton did. He went back, coaxed, flattered, managed the Royal Society, and when the Society ran out of money, it had overspent on a book about fish. Halley paid for the printing himself, out of a salary he could not spare. Newton wrote for 18 months at a pitch that alarmed his servants, forgetting to eat, sleeping in his clothes, writing standing up. In 1687, the Principia appeared, and the universe became one system with 3 laws in it. Now the part that gets left out of the textbooks. Newton wrote roughly 1 million words on alchemy, the transmutation of metals, the search for the philosopher's stone, and about the same again on biblical prophecy and theology, including a calculation that the world would not end before the year 2060. He was not dabbling. He worked at furnaces for decades, in secret, and by his own private theology, he was a heretic who denied the Trinity in a college named for it. When the economist John Maynard Keynes bought a trunk of these papers at auction in 1936, he read them and wrote that Newton was not the first of the age of reason. He was the last of the magicians. And it is one mind, not two. The same conviction drove all of it, that the universe was a coded message written by a lawgiver, and that a sufficiently patient man could read the code. Gravity was one line of it that happened to be decipherable. He gave the rest just as much of his life. In 1696, after a breakdown and years of restlessness, Newton left Cambridge for what everyone assumed was a comfortable retirement job: Warden of the Royal Mint. England's coinage was in crisis. Silver coins were being clipped at the edges until the money was worth less than its face, and something like 1 coin in 10 was forged. Newton treated it as a problem to be solved by data and pursuit. He drove the great recoinage, and then he did something no gentleman in the post had ever done. He had himself made a justice of the peace, went into the taverns and prisons of London in disguise, took depositions from hundreds of informants, and personally built the cases. Counterfeiting was high treason. Under Newton, at least a couple of dozen coiners went to the gallows, including his great adversary William Challoner, who had been clever enough to accuse Newton of incompetence in a petition to Parliament, and who died at Tyburn in 1699. The gentlest possible reading is that the man who wrote the laws of motion also personally hanged the people breaking the law of the realm. He died in 1727 at 84, the first scientist in history to be buried with a state funeral in Westminster Abbey, carried by 2 dukes and 3 earls, while Europe wondered what England had just lost. So what did he know? First, the emptiest room can be the most productive one. The plague year gave him 18 months with no lectures, no rivals, no correspondence, and he got more done in it than most fields manage in a century. The isolation was not an interruption of the work. It was the condition for it. Second, when the tool does not exist, build the tool. He wanted to describe change, so he invented the mathematics of change. He wanted a better telescope, so he ground the mirror himself. Third, the warning: the drawer nearly ate it. Everything he found in that farmhouse could have died with him, and it survived because one persistent friend rode out to Cambridge, asked the right question, and then paid the printer. Next time, a teenager who could not read or write walked into a royal court with no rank at all and left with command of an army. Joan of Arc, what she knew.